Hello and welcome back to my crazy electronics videos. In my previous video I highlighted what I thought was a hardware bug in the DMA RAM transfer from the expansion RAM to the external video and audio hardware that I've been working on. And I thought that the 13th latch register was conflicting with this general bus transceiver that allows the expansion RAM to be read and written. So I had a look at the test data that I've been using for the digital data generator in the schematic simulation software that I use, which is Proteus simulation and also PCB design software, all combined together. So I had a look at this test input data, and I could see where I was setting up the DMA and where I'm still reading latch 13 there, for where the DMA should be in progress, and then the next read it should be marked as complete. So I had a look at the debug output data, which is recorded actually from the hardware simulation. So I have a hardware digital data recorder, and I log all of the data to text files like this. So the enable DMA counter, the in progress DMA transfer, where that register is being read, and then it's still in progress with this read. The next cycle, the read should actually, and then I noticed the read actually should come back as FE, not 0. And because I was testing for 0 or 1 in the code, this reminded me actually that the code was wrong. Because look, the latch here, which is register or latch 13, has 7 floating input signals, and of course those are going to float high, so the output is also going to be high for the entire 8-bit latch, apart from that single signal which indicates when the DMA was in progress or not. So yeah, the code looked like this originally, which is what I was testing with in the previous video, and I thought that there was a hardware bug, right, because I thought that the code was right, but actually the code was wrong. I should have been masking out the bit that I want to test with on that register, on that latch 13, which is only the signal. The lowest bit in the byte there is actually the signal. So I updated the emulation code to reflect more exactly what should be or what is in the hardware. So actually all of the rest of the signals float high. It's just that the lowest bit needs to be set if it's in progress and then clear if it's not. So when I run this now with the updated bit masking in the Commodore 64 side of the code, it actually works in emulation still. So then when I run it on the actual Commodore 64 with the real hardware, so let's turn on the real hardware. I'm just switching the input here to the real hardware output. Good, that's the pseudo-random, default state of the hardware when it switches on with no programming whatsoever. I then run the Commodore 64 code there. This is the video test card, which is like the, the self-test mode at the beginning of the code. And then it's waiting for fire to be pressed. So I press fire, and we should see a little flicker on the screen in the middle. There we go. It's very difficult to see because it only goes on for 1/60th of a frame. And there we are. The Commodore 64 says DMA complete. So I'm reading the correct DMA complete bit now by extracting that bit using that AND from the byte, because the register is 8 bits wide, but only the lowest bit is the signal bit being used for the DMA and status or complete status. So there we go. And when I was just recycling the DMA there, it all works. So thank you very much to PCBWay. Actually, the hardware is fine. It was a software issue. And this is why it's important to use simulation tools, because using simulation tools and having the correct test input data and actually properly looking at the output recording from the simulation actually allowed me to debug the problem and find out that the simulation and the hardware design was all perfectly fine. It was just a problem with the software side of things. So the software driver running on the Commodore 64 rather, was wrong. So let's just double check that everything is still okay with the rest of the demo code. So let's run the Shadow of the Beast demo, which is inside the Easy Flash cartridge on the Commodore 64 plugged in there. And there we go. The Shadow of the Beast demo, title screen demo is working exactly as it should. The extended interface is running in pass-through mode in this demo because it's not using any of the DMA functionality currently. It's using the APU and all of the scaled sprites and normal sprites and the tiles layer and the characters layer, of course. And the APU allows those rather lovely background graduation, color graduations there, color gradients rather, and of course also the parallax scrolling layers as well. The APU is handling the raster splits there for the parallax scrolling layers. So yes, all that works perfectly well. So if you like these kind of crazy electronics videos, then please do consider liking or subscribing to this channel, and I hope to catch you around next time.